Q6b, we do the same thing as in the previous question. So we first check whether the sum n from 1 to infinity of absolute value of minus 1 power n ln n over n converges. Okay, and this is basically the sum from 1 to infinity of ln n over n, because if you have absolute value, the minus 1 power n will just disappear, and the ln n over n, if you take absolute value, notice that the term inside, it is always positive. So absolute value of positive number is just itself. Okay, so actually this series is just this. So okay, let's see what test that we can use. So limit test. Can we use limit test? Limit test is very easy to check. We just need to take the limit as n tends to infinity of ln n over n, and this is infinity over infinity, so we can apply Hospital rule, but we need to change the n to x, and we will have limit x tends to infinity of 1 over x, and this is 0. So it means that we have no conclusion from limit test, so we cannot use. For integral test, looks like we can use integral test, but I will choose to skip this because integral test is the most tedious one. It is the longest one. So if I see that I cannot use the rest, I will go back to integral test. Okay. So now let's see whether we can use comparison test or not. But yes, we can use comparison test. To see whether you can use comparison or test or not, you really need experience, because there is no rule for you to choose which sequence to compare, right? So you need to experience, do more questions and get experience. Okay. So we will use comparison test. So we have this ln n over n. This is actually bigger than or equal to 1 over n. Since for n is greater than or equal to 2. No, greater than or equal to 3. Right? So, okay, this is because ln n is bigger than or equal to 1 if n is bigger than or equal to 3. Okay? So, by comparison test, we have since too fast. Since the sum n starts from 3 to infinity of 1 over n diverges, then by comparison test, the sum n starts from 3 to infinity of ln n over n diverges. Okay, this also implies the sum n from 1 to infinity of ln n over n also diverges. Okay, so we are unlucky because this means this is not converged absolutely. So we need to check whether this converges or not. So next, we check whether the sum of minus 1 power n minus 1 ln n over n converges or diverges. Okay. So if we do limit tests, you will have no conclusion. Okay, you will have no conclusion. So you cannot use limit tests. For integral test, comparison test, limit comparison test, ratio test, root test, all of this you cannot use because you need the terms to be more than or equal to 0. So this is your only choice, and you see the form is similar, so we are very lucky. So we need to apply Leibniz test. So to apply Leibniz test, we need to check whether, let's say this is Pn. Okay, I have the test here. Maybe I just okay, we will apply this test. So we need to say that this is my Bn and check whether this Bn is more than or equal to 0 or not. But it is very clear. Clearly, Bn is more than or equal to 0. For all n, right? For all n. From 1 to n. Okay. And this Bn is decreasing. Okay. Why? Why is this decreasing? Because okay, let fx be ln x over x. Okay, if this function is a decreasing function, then in particular f of n is equal to ln n over n will be decreasing, right? X is more than to 1. Okay, so how to check whether this function is decreasing or not? We can just take the first derivative. Okay, so we have, it's lagging, we have f prime x is equal to 1 over x times x minus ln x divided by x squared. So this is 1 minus ln x divided by x squared. Okay, and this is it is less than 0 for x is more than let's say 3, right? More than or equal to 3. So fn, which is bn, is decreasing for n is more than or equal to 3. And we also have limit n tends to infinity we also have limit n tends to infinity of ln n over n. How to compute this limit? Just need to change the n to x and apply Hopital rule. And this will be 0. So by Leibniz test, this converges. And this means the sum n from 1 to infinity of minus 1 power n minus 1 ln n over n converges conditionally. Done.